Okie dokie, Lexi, and here comes lesson 59, number 24. Okay, I'm looking at this piece of paper. It actually turned out to be kind of a darker color, didn't it? I think that's because this one, I took a picture of it underneath a different lamp, so it's a little bit on the yellow side. Oh well, anyway, let's go ahead and take a look at it. Lesson 59, number 24. What we have here is we have a quadrilateral. It's a four-sided shape. Makes it a quadrilateral. Its name is LPRS. We are also told up here that PT and RS are parallel. So PT and RS are parallel, and they're also congruent to each other. Alrighty, so that's kind of cool because now what I see here from that is, and I'm going to mark this in a different color. This right here, it looks to be like a parallelogram then, because it has the opposite sides are parallel and congruent. And if you remember, in a parallelogram, if you have parallel lines, oops, I made that a little bit off here. If you have your parallel lines that are congruent, even if just these two right here are congruent, that's going to make these two congruent as well. Okay, so remember, a parallelogram has two pairs of parallel lines, and also the opposite sides are congruent to each other. Okay, so that's some valuable information for us to kind of bank for a moment. Let me get rid of some of this drawing up here so it doesn't get too busy. All right, so let's go ahead and write down what's given to us. We are told that we have quadrilateral, LP, RS, and also we're told that PT is parallel to RS, and PT is also congruent to RS. Now I'll go back up there and I'll mark those. So PT and RS are both parallel to each other as well as congruent to each other, which we already established. Then what that means is we now have a parallelogram. I'm going to draw the symbol for a parallelogram right here. And the reason is already here. And you might want to write here, this is theorem number 40. If one pair of opposite sides is both parallel and congruent, then the quadrilateral is a parallelogram. Okay, so that's why we can legally make the statement in number 2 that PRST is a parallelogram. Number 3, if that is true, let's see, if we have this parallelogram up here now, I'm going to highlight it in yellow, then that means that PR and TS are also parallel to each other. So we're going to go ahead and write that in here. PR and TS are parallel, which also then would make PR, let me do this one now in a little bit of a different color here. That also means that PR would be parallel to this whole line LS. Okay, and that's what you see written right here. And that is simply the definition of a parallelogram, which is definition number 45, which says a parallelogram is a quadrilateral that has both pairs of opposite sides parallel. Okay, which basically they're referring to that parallelogram inside there. Okay, but the reason we can make this part here, we can make that statement, is because that line just simply extends over. Okay, you can see that I'm drawing that a little bit thicker up there. All right, now we can say that LPRS is a trapezoid, because all as we needed for a trapezoid is to say, remember, let me draw this down here. A trapezoid has one pair of parallel lines. They don't have to be congruent. They won't be congruent because these legs right here make it not so. But now we can say that LPRS is in fact a trapezoid. And definition number 43 is where that comes from, which states that a trapezoid, let's see here, definition 43 can be found in our packet there on page 762. And it says that a trapezoid is a quadrilateral which has exactly one pair of parallel sides, which we've already marked right here. And the parallel sides are called bases. Okay, so those that are marked parallel are called the bases, and the non-parallel sides are called legs. So these right here are your legs. And in this case up top, this is a leg and this is a leg. And the parallel sides are both called bases. Okay, that's all part of definition 43. I'm sorry, it's not on page, I gave you the wrong page number. It's 761. I was looking at, at first I said theorem 43. I said definition 43, but I was looking at theorem 43 on page 762. But the definition 43 is on page 761. But basically, I just wanted you to understand that on a trapezoid, it is a quadrilateral, it's four-sided, has one pair of parallel lines, and those parallel lines are called your bases. The other two non-parallel lines are called legs, but that does complete the proof. We were able to work through that to prove that LPRS is a trapezoid, and that ends the information for number 24 in lesson 59. Okie dokie, thanks for watching.